Welcome back. All right, let's take a look at another example. Let's do just like a rundown of solving word problems. Draw a diagram. I think that's very helpful to visualize it. Label the parts. There's some unknowns. Maybe you've got some specific values. There's some other geometric formulas that you should know. Write those down. Build up to the specific information that you're given. You need to ultimately create a single equation that has a single independent input variable that you then can use to answer any of the other questions that come along. If you are able to kind of intuitively get these numbers for the final answer, you need to know how to do the equation in addition to, your intuition like that. So I got a box. I label the parts. We're told the base is square. Use the letter X. I got the height. Use the H like that. So I know some of the formulas like that. Started with some, I got the base is X squared, the area, volume of a box, multiply the three dimensions together. And so for this box, I can kind of get partially to the one letter I need, X squared times H. So I need some more information to have a volume that just has X as its variable. So the next bit of information talks about the edges. So we need to make sure we know the total number of edges that will add up to the length that is indicated. So squares have four sides. There's two squares, top and bottom. And then the rectangles on the sides, there's four edges for those. So 12 in total. And so if we got 4 of the heights and 8 of the x's, they add up and they equal 169, the value we're told, like that. All right, so with that, I am going to plug that into my volume. I'm going to first solve it for x, solve it in terms of x. So my height is equal to, you can see how I solved it there. Now I'm going to plug it into the volume equation, x squared h, and I have this volume equation that if you are, some of the homework, I think there were 1 or 2 or 3 that asked you to maximize the volume. You do need to use a graphing calculator or Desmos.com or something else. So you immediately know questions like that will not be on the test. You have to be able to create the equation, definitely, and then other questions you'll be able to solve with the correct calculator, like that. Okay, our follow-up question is just the domain. So if you think about this is just a polynomial, right? It's a third degree polynomial. The domain of our polynomials, negative infinity to positive infinity. But that is not the correct domain for a box. One, we can't have any negative dimensions, so it's got to start at 0. And there is ultimately a maximum based on that all of the length of the edges is 169. So how do we then figure that out? Well, our volume equation is in factor form. And if we take each factor and set it equal to 0, we can figure out the value where it could be negative and we don't want it to be negative. So anything in between those values will work. So nothing negative, not 0. And then if we get larger, then the value that makes the next part factor equals 0. If we get larger, yeah, I said it correctly. If we solve the factor and then any value larger than that number will make it negative. So we have to stop there. That's our minimum and maximum values in our domain. And we didn't have any more questions for this one, so we're done.